All right, hello everybody. I'm going to try to make a quick video about some of the basics of momentum. So let's get started. Momentum can be a kind of odd thing to try to describe because it tries to describe how much motion is happening. So anything that's moving has momentum. Now, the difference is that a small object, maybe like this, could have a certain amount of velocity, say 2 meters per second of velocity, and this bowling ball could have 2 meters per second of velocity, but they'd be very different experiences for the whiteboard, right? 2 meters per second for that small little foam baseball is nothing. 2 meters per second of velocity for this bowling ball is significant. So that's where the idea of momentum comes in. It's the mass and the velocity of an object describes how much something is moving, how much stuff is moving. And so the formula for momentum is mass times velocity. Now it's very significant to acknowledge which direction is the momentum. So for instance, when this bowling ball is already moving, if its velocity is that way, its momentum will be that way. If I want to get it to stop, I'll need to push in the opposite direction. So that's why we just need to keep track of which directions the momenta are. Okay. Let's talk about amounts of momentum. Now, I've got a bowling ball, it's at rest. I've got, again, one of these little squishy baseballs. It's also at rest. Now, at the moment, neither of them have any momentum because no velocity, no momentum. But if I get them moving, which will have more momentum? Well, it depends entirely on how much they're moving. You could imagine that if they had the same velocity, well, the bowling ball would have more momentum because it has more mass. But imagine the baseball is moving much, much faster than the bowling ball, in which case it's possible that the baseball could have more momentum than the bowling ball. You'd need to just plug in the numbers and figure out for sure. There's no great way to predict which would have more momentum unless you actually know the momentum is there, or you know that the velocities were the same and the masses are different. So let's talk about units for momentum. Well, since it's mass times velocity, I'm going to have mass in kilograms. When you multiply by velocity, which is in meters per second, the units for momentum end up being just a squish of that, kilogram meters per second. So momentum is measured in kilogram meters per second. It doesn't have any fancy short name. It's just one annoyingly big unit. Mass is in kilograms. Velocity is in meters per second. Now you can see up here that I don't have a symbol for momentum yet. I was hesitant to write that right away because it's a weird one. You'd expect it to be something like an M, but M is already mass. So at the end of the day, momentum gets an odd symbol. It gets a P. P equals MV. P is the symbol for momentum. All right, thank you.